Hi everyone. So now we are going to talk about paramagnetic materials, the second time. You might have heard the word paramagnetism before, and let's talk about paramagnetism and paramagnetic materials. So as we know, like in magnetic materials, like in some magnetic materials, there will be like there will be magnetic moments which are actually the vector sum of orbital and spin magnetic moments. Okay, this will be the vector sum of orbital and spin magnetic moments. But in those cases, the net magnetic field will be, the net magnetic moment will be 0. Why? Because of the random direction. The orientation will be random. Okay, so that we have already seen, or we have already covered. Okay, but the question is how this material will behave in external magnetic field. Okay, so for example, let me tell you something. In the presence of an external magnetic field, the torque acting on the material or torque acting on the individual molecules, that will be aligned in the direction in parallel to the magnetic field. Okay, that is a property of paramagnetism. Okay, as a result, there is a net magnetic dipole moment induced in the direction of applied field. So that is what we haven't seen in the case of diamagnetism. Okay, and so the induced dipole moment is present as long as the external magnetic field exists. That is very clear. That magnetic field will be present as long as the external magnetic field. If you remove external magnetic field, there will not be any induced field over there. Okay, so when it is placed in a non-uniform, like do you remember how we discussed in the case of diamagnetic materials, when it will be like when we apply a non-uniform external magnetic field, then here the paramagnetic materials will have a tendency to move from weaker to stronger side. Weaker to stronger side. Note the point. So of the field. So materials which exhibit this type of magnetism are known as paramagnetic materials, and this particular property is known as paramagnetism. And what are the examples? There are a couple of examples given. This first one is aluminium or chromium. Okay, these are the examples. And let's see the same, like the properties of paramagnetic materials. Let's talk about that, because we have already seen that in diamagnetic materials. So compare diamagnetic materials and paramagnetic materials. This is one of the very popular question. One of the very popular questions from board exam. All the board exams. So compare paramagnetic and diamagnetic. Okay. So let's talk about that. What about magnetic susceptibility? It is positive and small. In the other case, it was negative. In diamagnetic materials, it was negative. And again, relative permeability is greater than unity. So relative permeability mu r is greater than 1. So then the magnetic field lines are attracted into the paramagnetic materials, are placed in a magnetic field, external magnetic field. External magnetic field. Okay, so then susceptibility is inversely proportional to the temperature. Susceptibility is inversely proportional to temperature. So then, in addition to this, we have to discuss one particular law which refers to paramagnetic materials, which is Curie's laws. So what is Curie's law says? So it is very simple. It is given in the same page number. So when temperature increased, the thermal vibration will upset the magnetic moments, dipole moments. Okay, so the thermal vibration will always upset. Thermal vibrations will always upset the individual magnetic moments. So what will happen if temperature increases? If temperature increases, we are increasing the temperature. Then what will happen? The psi m, the susceptibility, will be inversely proportional to temperature, or psi m is equal to C by T. That is the equation. So look at this. If it increases, if temperature increases, then susceptibility decreases. So this phenomenon or this particular law is known as Curie's law. And this C where the constant C is known as Curie's constant. Curie's constant. So the graph is very important. So you have to understand the graph and the law only. Okay, that is only we need, and there are no problems or numericals with this. And at least you have to understand what is Curie's law, how it affects the paramagnetic material, etc. Okay, thank you.